All right, guys, we're going to do a little experiment. If you have a calculator, exactly what I write down is what I want you to plug into your calculator, exactly like I write it. Type that in your calculator and hit enter. Tell me what your calculator says. Negative 16, okay? What is negative 4 squared? Positive 16. So why is your calculator telling you negative 16? You need parentheses. Okay, guys, I mean this, and I'm going to say it a bunch, and I mean it in the nicest way possible. Your calculator is only as smart as the user. Right? What you put in is what the calculator is going to give out to you. I am stressing this because a lot of this is calculator work. And if you don't put it in the calculator correctly, you're not going to get the correct answer out. What this says right here, the way that it's written and the way that you plugged into your calculator, order of operations, parentheses first, then what? Exponents. So what your calculator does is your calculator says, okay, great, I'm going to square 4, and then I'm going to multiply it by negative 1. In order for you to have the calculator multiply negative 4 by itself twice, you have to put it in parentheses. Anything that's negative, guys, give it a hug, right? Give it a hug. You've got to do that. It's going to be important in a little bit when we start our interest problems because you're going to have like this big long formula and then you're going to raise it to like the 2 times 9 power. Yes, I understand you guys can type in 18, but some of you might actually type in the time value versus with the compounded. You'll see what I mean in a second. If you don't put your exponents in parentheses, what your calculator will do, say you have like 4 to the 2 times 9, your calculator will raise 4 to the 2nd power, then raise 16 to the 9th power. You have to say, hey, I want that number to be raised to this value. Anytime you have calculator questions, as long as it's not on a test or a quiz, ask me because we need to iron this out now. There's a button on your calculator that looks like that. It's called the caret button. That's how you raise something. There's a negative button on your calculator. You cannot use the negative button as a subtraction, and you cannot use subtraction as the negative button. Your calculator will tell you there's an error. So just little stuff. Some of you have real fancy calculators and absolutely have no idea how to use them. I'm going to help you, and we're going to learn along the way as we go. I'm going to teach you different stuff. It'll be helpful, probably stuff that you're like, oh man, that would have been helpful to know on the SAT. But just make sure that you guys are practicing with your calculator and asking questions. If you don't have one and you're borrowing from someone, try to borrow the same one all the time because a lot of them are different. Chris, quit. All right, today we're going to talk about the mathematics, the computation behind logarithmic versus exponential functions. Yesterday we graphed exponentials. Either tomorrow or Monday we're going to graph logarithmic. You guys are going to have a quiz next week. And it's going to be a calculator portion and a non-calculator portion. So part of it you're going to be able to do by hand. You don't need a calculator. Then the other part you have to do it with a calculator. We'll talk about that a little more next week. But what did I tell you yesterday about exponential functions and logarithmic functions? They're what of each other? Opposites. They're inverses. Okay, these are inverses. Just like multiplication and division are inverses. Addition and subtraction are inverses. When we get to solving in 3-3 and 3-4, the only pre-calc step is to understand if you have an exponential equation, in order to undo the exponential equation, you have to turn it into a log. In order to undo a logarithmic equation, you have to use exponentials. So that's where we're going to be going with this. But I just want you guys to see you're going to see the difference and how they're related here. We're going to talk about some properties. And then we'll go to some interest problems, but it's really not bad. First of all, the two forms. We have logarithmic form and exponential form. You should be able to look at that and tell me what form is what. What do you notice is in the logarithmic form? The word log, okay? What do you notice about the exponential? It has a base and an exponent, all right? So it should be really easy for you guys to differentiate what form we're starting in and then to which form we're going to go to. I know some of you have you have some like little tricks I've seen you do with your hands and you say different acronyms, whatever. Our brains think exponentially. If you were given this, you guys are like log base 2 of 8 equals 3. I don't even know what that means, all right? If you hit the word log on your calculator is in log base 10. It's not in log base 2. I'll teach you how to do change of base in a little bit, but What is that question saying? What we're going to practice now is going from logarithmic to exponential form and evaluating and vice versa. So how do we do that? This right here is in logarithmic form, correct? We're going to go to exponential. So this little base, when we go to exponential, becomes our big base. So I'm going to rewrite a big 2. And I'm going to emphasize, guys, when I say a big 2 and stuff, you'll see when we get to solving. And what happens now is these two things switch places. So 3 becomes my exponent and 8 becomes my answer. Now, doesn't that make sense that 2 to the third power equals 8? All right, that's how our brains work. That's exactly what this says here. Log base 2 of 8 equals 3. That's exactly, these two things mean the exact same thing. We just think this way, not in terms of logs. So we're going to kind of practice going through some examples of that. So look, we're in logarithmic form or exponential here. Okay, so I'm going to write 4 equals log little 2 of x. Now they're asking us to evaluate, write an equation in exponential form, then to evaluate it. So we're in log form, we see that. So my little base becomes what? A big 2. All right, your log goes away. And then what happens with the x and the 4? They switch. My x comes up here and my 4 goes down here. Now can you guys figure out what the x equals? 2, right, x equals 2. 2 squared equals 4. Anytime you guys are in a logarithmic equation, just change it to exponential and then it's easier. Same thing here. My little 3 becomes big. The log goes away. And what happens with the x and the 9? They switch spots. So 3 to what power equals 9? X equals what? 2. So we're going to practice going from one to the other. And then we're going to talk about some properties. And then we're going to do a couple problems. All right. What form are we starting off in here? Exponential. So we want to go to log. Okay. So let's do A right here. My big base, what do you think is going to become? My little log became big. So my big base is going to do what? Become little. I'm going to write the word log. And then I'm going to put my b teeny tiny. And then what's going to happen with 4? What's going to happen with 16? They switch places. What does b equal? 2. You guys should be able to look at that. What does x equal in b? X equals what? 25. Okay, but if I was going to write this in log form, my big 5 becomes what? Little. I write the word log, and this becomes little. And then what happens with the 2 and what happens with the x? They switch spots. That's it. That's it. Yep.
Back to the last page.
All right, let's talk about this. Evaluate without using a calculator. What are they telling me that x equals? 64. Okay, so what this is looking like, this says log 4 of 64 equals what? We're not exactly sure. We're not exactly sure what that means. So let's rewrite it exponentially. So what happens to my log? Crosses off. What does that little number become? Big. And then what happens with my 64 and my question mark? They switch spots. Can you answer that question now? 4 to what power gives us 64? 3. When you evaluate this, the answer is 3. Turn everything that's in log into exponential, and it's much easier to see, right? This one's a little more difficult. Log 36 of 1/6 equals what? How could I go? Let's just think for a second. How can I go from a whole number to a fraction? A negative what? A negative exponent, okay. What's the relationship between 36 and 6? 6 squared? Or what's the square root of 36? 6? Okay, so what this looks like, guys, and this is what you need to think of. When you see like a big number go to a fraction, you need to think negative exponents. That's really good. You also need to see correlations between the numbers themselves, 6 and 36. 6 squared is 36. Square root of 36 is 6. You'll see that with cubes and stuff too. But if you were going to rewrite this exponentially to figure it out, log would go away and 36 becomes what? Big. Then what happens to the 1/6 and the question mark? Okay, so this goes up here, here. So think about this. Both of you, your answers were good. What's the relationship between 36 and 6? Well, the square root of 36 is 6, correct? What's the relationship between 36 and 1/6? A negative exponent. So how would you write an exponent to say that you're going to take the square root of something? What about if I said 36 to the -2 power? What does that look like? 1/36. Okay, that's not what I need. Part of it's what I need because I need the negative. But how would I make 36 become a 6 using an exponent? I agree with square root, but you can't have square roots in a denominator. So how do we represent that? It is a half. Good. This is -1/2. All right, we need to think. We cannot think about this because you guys are on the right track, right? We had to think for a second, so now we're upset. I agree that the square root of 36 is 6, but you can't have radicals in the denominator, can you? So what is the index here? What's the little number there? It's a 2, right? And this is to the first power. Do you guys remember from Algebra 2 how you go from radical to rational? Your index becomes the what? Denominator. So this is 36 to the 1/2. And since it's in a denominator, it's negative. We'll see a few more of those, but that's very good thinking. When you guys see fractions, you should think negative exponents. And when you see numbers square rooting, you should think fractions, fractional exponents. We'll see more of those in a second, but good job thinking. All right, calculator, blah, blah, blah. We'll look at that later. Calculator stuff, we'll do more of that tomorrow. All right, I want to talk about the properties of logs. After I go over this slide, you guys are going to say, oh, can we have like 12 of these on the quiz? We won't have a bunch of them, but these are like gimme questions. It's easier to see when we put numbers in place of letters, but I want you to see. You notice on the left, it's in log form, and on the right, it's in exponential. So it says log base a of 1 equals 0, or a to the 0 power equals 1. Think about it, guys. If I were to take this and to turn it into exponential, my log would go away, the a becomes big, right? Then 1 and 0 do what? They switch spots. Anything to the 0 power is what? 1. So a question you might see is like log 6 of 1 equals 0. And you guys are like, wait, what? I don't have a calculator, I can't do that. Well, think about it. Go from log to exponential. If I were to rewrite this, what happens? Log does what? Goes away, 6 becomes big, and what happens with the 1 and the 0? So 6 to the 0 power is 1. Anytime you have log with a number, and it's set equal to 0, like log base, whatever, 1 equals 0, it's always going to be like this, always. You'll see in a second with actual numbers. What do you notice about this one? It has the same variable, good, because this is log base A, and this is a big base A. What did I tell you guys that inverses and exponentials were of each other? What's the word that means opposite? Inverses, good. So when you have inverses and they cancel out, what are you left with? It's not 0, what are you left with? 1, okay? Same thing here, what do you notice? Same variable, the little base is the same as the big base, so what happens? They cancel out, so whatever the exponent is equals this, and I'll show you with numbers in a second. Same thing on here. What do you notice about the left-hand side of the equal sign and the right-hand side of the equal sign? They have the same little base, right? Well, once you have the same little base on one side and the same on the other, you can just cross it out. And then 1 equals the other. So let me show you some of these in real time. We can already do this. God bless you. Do this real quick, and then we'll go to some examples. Rewrite this exponentially. What does this say? 3 to what? The x power equals 81. What's x equal? Perfect. What does this one say? 5 to the x power equals 1. X is perfect. 5 minutes ago, you guys couldn't do that. Whenever you have one of these logs where you have to evaluate, just change it to exponential and then it just makes more sense. That's how our brain works. It's the same. Whoops. All right, so here's basic property questions. You'll have one or two of these on a quiz. But when I have a base that is the same as the log, what do you think happens there? They cancel. These are inverses of each other, so your answer is just 15. Why is this important? Because that is how we're going to solve the equations. You might have log of something and you have to undo it, so you have to make the base, the little log, be your big base on both sides, make it equivalent. I'll show you. It's not bad, I promise. All right, what do you think happens here? They just cancel out, so what's left? A 1, good.
How come it's a 1 and not a 0?
It's like when something divides out, like 7 divided by 7 is always 1. What about here? So what's left over? Perfect. Trick question. Well, hold on. When I see a fraction, what do I think? Negative what? Exponents, okay? If you're not quite sure on this one, guys, change this to exponential. If I was to rewrite this exponentially, what would it look like? 3 to the x power equals 1/3. How would you make the whole number 3 become a 1/3? What power would you raise it to? Negative 1. Very good. Okay, yeah. Are you just dancing? Okay. Calculator stuff, we'll do that tomorrow. Okay, something called the one-to-one property. If you are given an equation and it says solve using the one-to-one property, that means you don't have to go through the whole solving thing that we're going to do in a couple days. What you're going to do is make the left-hand base the same as the right-hand base, because what happens when your bases are the same? What can you do to them? You can cancel them out, and then your exponents just equal each other. But what you need to remember, guys, is anything raised to the 0 power is what? 1, okay? So let's look at an example of these equations. You can't just divide both sides by 3 or anything like that, because this is not just a basic linear equation. This is an exponential. So if they tell you to solve using the one-to-one property, you want to make the bases on each side the same. So can I break 3 down into any other perfect squares or anything like that? No, so I'm just going to leave it as 3 to the x minus 2. Then I look on the right-hand side. I have 9. Can I rewrite 9 to keep the value the same, but with the same base of 3? What would it be? 3 what? 3 squared, okay. What do you notice about the base on the left and the base on the right? They're the same. That means you can cross them off, and then you set the exponents equal to each other. So x equals what? 4. Go back here and check. If I put 4 right here, what's 4 minus 2? And 3 squared is? There you go. Let's look at this one. This is not a trick question. You will probably see something like this, guys. What's the only thing x can equal here? 0. Think about it. Put a 0 there and look at it and be like, oh yeah, anything to the 0 power is what? 1. That's really important to remember. All right, let's look at the next one. What's my answer here? Why not 3? Why though? Okay, you got to make this 16 into a fraction. Okay, you can look at it that way. What's another way we could look at it? What happens? This is 2 to the first power, right? Can I bring this up here? If I bring that 2 to the first power to the top, this becomes 2 to what? The negative first power, right? And then I have an x there, and then I have 16. Whenever you start off with a fraction like this, they tell you to do 1 to 1, make it into a whole number. The way that we do that is when you bring your whole number, when you bring your denominator up, the exponent just becomes negative. So now can I rewrite the right-hand side with a base of 2? Two to the what? So 2 to the 4th power. Now that the bases are the same, I can say negative x equals 4. So, my dear Angie, what was it? X equals? Perfect. Good. Good, good, good. One-to-one's really easy, especially when they tell you solve using one-to-one. They're telling you you can make the bases the same on each side. Like it's mathematically possible. Okay, we'll talk about E more tomorrow. I told you about this yesterday. It's programmed in your calculator. That's that button. It's on the LN button, but we'll play more with our calculator tomorrow. I want to make sure we get to these interest problems because you have like 3 or 4 of these on WebAssign, and it's really important that you guys understand. This is a really, really, really simple concept, but get your calculator in your hand because you've got to know how to plug this in the calculator. You're going to have 2 or 3 questions on your quiz that it's just this. You have to know the formula and you have to be able to use your calculator. So make sure you guys are paying attention. Here is the formula when we're talking about compound interest. We'll talk about continuous in 1 second. But compound interest, you'll get problems and it'll say this certain amount of money is invested over a certain amount of time at this rate, and you just plug it in the formula. What you need to understand is where the values go that they give you. So P is your initial amount. They'll say $5,000 is invested into account. That's your principal. That's your initial amount. The next thing that you're going to talk about is your time. Time is what? In years. If it tells you 6 months, how many years is that? Half of a year. Okay, good. Everything is in terms of years. Another thing that's really important, guys, is your interest rate. Okay, say they give me the interest rate of 4.9%. What does it say right here that your interest rate has to be when you put it in your formula? In decimal form. Is 4.9% in decimal form? Nope. It's got a percent sign on it, doesn't it? How do you change a percent to a decimal? You got to move by, so your interest rate that you would plug into your formula is 0.049. I understand the interest rate has the decimal in it, but if that percent sign is there, then that means, I have to move the decimal place over too. That is going to make a huge difference in your calculations if you put 4.9 when it should be 0.049. Just please be aware of that. And then they're going to tell you how the money is compounded. You guys are like, what are you talking about? So they're going to give you, and they'll say, okay, we're going to compound the interest monthly. All right, this is where our vocabulary is going to come in. Monthly. What is my N value in terms of a year? How many months are in a year? 12. So if something is monthly, you plug in 12 for N. If something is quarterly, how many quarters are in a year? 4. How many quarters are in a dollar? 4. How many quarters are in a football game? 4. Okay, we're talking in terms. People are like, why isn't it 25? Because it's in terms of a year. If you cut the year into 4 pieces, that would be quarterly. Let's talk about, what about if it says daily? Okay. What about if it says weekly? You're the second person that said 57. It's 52. See? It's 52. It's 52. Google it. What about if something happens semi-annually? It's every 6 months, but how many times is that per year? Twice, 2 times. And then what about if something is yearly? Once, right? Those are common knowledge things that we need to know. You have to know what the word monthly represents in a number. It's 12. Quarterly represents 4. Daily represents 365. Weekly represents 52. Once you have that down, guys, it's super easy. We'll talk about continuous in a second. So let's do these questions. We're going to do all 3 of these, and I want you to see this. I'm going to show you a good way that you can catch and see if you made a mistake. All right, this is what a problem would look like. Super straightforward. It says find the accumulated value of an investment of $15,000. What do you think $15,000 represents? Your principal, what you start off with. Good. For 2 years, what letter is that? Time, 2. Interest rate of 3.2. That's going to be 0.032. Perfect. So I have the P, the T, the R, and then I look at each question individually for the N. So I'm going to use what number for letter A? 2. What number for B? 4. What number for C? Perfect. So now we're all going to practice because it's really important that you put it in your calculator correctly. If you have a Casio, you're going to have to Google it because I'm not really familiar with those, but most of your other ones I can help you with. So I have my initial amount of 15,000, and I have a parenthesis. 1 plus, it's always a plus because you're growing, the interest is growing. So it's going to be your interest rate, which is 0.032. Our first one is semi-annually, so over 2. And then we're going to raise it to the what? What is the formula? N times T, so 2 times 2. Or you can put 4. Notice how I put the parentheses on the inside, guys. You have to tell your calculator to do it like that. Put it in exactly like you see it. 15,000, then put a parenthesis. 1 plus, put a parenthesis. Then you have to go 0.032 divided by 2. Close your parenthesis twice. And then when you raise it, if you put 2 times 2, you need to put that in a parenthesis, or you can just put 4. But when you put that in your calculator, what do you get? 15,000. Somebody, what else? Anybody else get anything? Tell me, Carl.
Nothing much wrong. I got 15.
So say, it shouldn't be 15 point. It should be 15,000. How much? 483?
I got 15,983.
983, I believe that's correct. 983 point what?
2867.
2867, so 29. Guys, we're thinking money, right? Do the next one. What changes in my letter B? Does the initial amount that I put in change? No, still 15,000. 1 plus, does my interest rate change? Nope, still 0.032. What changes? How we compounded the money, correct? How did we compound this money? For B. Quarterly. So this is a 4 down here. So close, and then you're going to raise it to what power? 2 times 4, which is 8, or you can put 2 times 4, it doesn't matter. Now throw that in your calculator. Everybody practice. Worry about parentheses and all that. Okay, hold on. 15,000. Say it again. 987 point. All right. All right. Look at the difference between these two numbers. It's a difference of $4. Everybody see that? What's the difference from what you originally put in to what you guys just got? About $1,000? Why am I bringing that to your attention? Because some of you will start off with a problem like this. You'll put all this in, you'll hit enter, and you'll tell me it's 7.3 times 10 to the 43rd. That's what my calculator says. Your calculator is only as smart as what? The user. You guys have to put everything in correctly. Your initial balance, whatever you start off with, your initial investment, once you work all of these interest problems out, it doesn't matter how you compound the interest, it's not going to change by billions. So if you do something in your calculator and it tells you an error or the number jumps just like ginormously, go back and check just to make sure you put it in correctly. It's little ways to kind of check yourself. Look at C. We did C. Again, what changes in C? I still have $15,000 that I'm putting in. I still have 1 plus. My interest rate is still 0.032. But how are we compounding the money in C? By 12, okay? Monthly. So let's see what happens here. So I'm going to raise it to the 12 times 2 power. 24, okay? Throw that in your calculator. Tell me what you get. 15,000. 998.
No, 990.
990. Okay. And then some change.
22.
Okay.
No, it's
02 or 20? Okay. Again, is there a huge difference between these three numbers? No. If you guys are jumping by millions and billions of dollars, you missed your decimal place somewhere. You forgot a zero or something like that. I'm just trying to help you troubleshoot. Now, we didn't do this problem yet, but we're going to it right now. What about if they say compounded continuously? Well, in this case, continuously, you don't have an n value. It's a different formula. It's called APERT. A equals P E R T. This is continuous, only when it says continuous. So you're going to take your 15,000, and then you're going to find your E button. Look on your calculator. It should be second, and then the ln. ln and E, they're inverses of each other. They're on the same button on your calculator. So you hit E, and it'll go like that, and then it brings up an exponent, and you put the rate and the time. So 0.032 times 2. If you have questions, look around, ask me, but it's on the ln button. Like ln's like this, and then the E to the X is above it. So you generally have to hit second. But continuous, this is for continuous, you use APERT. 15,000, then hit second ln, the E will come up, and then you raise it and you put the rate and the time in there. And what do you get? 15,000, what is it? 991. And some change, some 39, okay. Again, not a huge difference from all the other answers and your initial balance that you started off with. So you guys have questions on WebAssign that you have to do this, and it tells you to round to the nearest cent. Please don't just put random amounts of numbers into WebAssign. You're talking about money, guys. How many decimal places is money? 2, okay.